So last session, it seems that we've managed to have a critical mass of lightning talks. So we will have a lightning talk session. So it will be after this talk, and then we'll have the closing, and it's over. So pick the max or whatever leftover you have, and you're free to go. So next talk, an architecture to do them all by Jesús Sánchez. Yes, an applause for him, please.
Thank you very much. I'm the last one. I don't know if that's good or bad, but
Good.
First of all, I want to say thank you for all the sponsors, for the organization, and for Campus Madrid. Thank you. And I'm Jesús Sánchez. I'm working at Synergic Partners, which is one of the sponsors. But don't worry, it's not gonna be a boring talk. I just wanted to talk about one of the last projects that we did. It was, well, let's start. We went to the client and they told us, okay, we want to visualize everything in a dashboard. And I say, okay, but everything, it's a lot. I mean, if you want to see that kind of stuff, it's like something like magic. So they told us, okay, not everything, just the incidents. And the incidents could came from several databases and Twitter. You know, the name of this talk is an architecture to tweet them all. So let's tweet them all. The idea was easy, okay? We have to get the tweets, do something with them, and visualize them. So I put it in a draw. We have a collector, which is going to get the tweets. We have an analyzer, which is going to do something with them. And we have a visualizer, which is going to visualize them. And the only thing that we have to do is to connect them. Easy. And that's all. Thank you very much. No, I'm kidding. I want to stop here, because when I was in the university, they told me, when you find a problem, you have to when you get a problem, you find for a solution, and finally, you get the tools, okay? In that order: problem, solution, tools. Problem, solution, tools, okay? Not another order. Because if you have a tool that you love, it's like you have a hammer, and every problem is a nail. So problem, solution, tools, always. Always or not, okay? When I went to the client, the project was coming with that kind of things. We had to use Spark Streaming and ELK, ElasticSearch, Logstash, and Kibana. Okay, well, no Logstash. We are not going to use it. So the draw is now much better. We will use Spark Streaming in the collector to get the tweets, and we will use ElasticSearch and Kibana to visualize them. ElasticSearch as an indexer. So Elasticsearch is an indexer, okay. We need a database, okay. Elasticsearch is not a database, just put it on your mind. So in order to get a database, I think that we choose CouchDB. Why CouchDB? Because it's NoSQL, it's document-oriented, and we have not used it before, so we want to learn more. We wanted to use something new, and we thought that CouchDB is good. Why document-oriented? Because the tweets, we get the API from Twitter. The tweets are in JSON. So we don't know what the client wants, so it's better to take all the tweets, to put it in the database, and then we will find what they want. Maybe in a second iteration, we could choose a SQL database. But anyway, when we told the client, okay, we want CouchDB, they told us, CouchDB? What's that? You have only HBase or Hive, because they had Cloudera and that kind of things. Both are over HDFS. HBase is NoSQL, is key-value, and it has no use MapReduce. And at the other hand, with Hive, we have SQL, MapReduce, and because they are using Cloudera, we have Impala. we choose Hive because of Impala. Okay, we don't want the queries for the key value NoSQL database. We don't know what we want to query, so we prefer move everything to SQL and using Impala. So no code. Let's go to Hive. In order to communicate, the idea is when the collector gets the tweets, it's going to put it in the database, and somehow you're going to say to the analyzer, OK, let's go, analyze it. And for that communication, we think that message queuing, like RabbitMQ, is a good idea. The collector is going to put the tweet here, and it's going to send the ID of the tweet as a message. And the analyzer is going to get the ID and do that stuff. But we say, OK, Rabbit. They told us, we don't have Rabbit, just Kafka. So, OK, let's go to use Kafka. Now I'm going to go one by one to the stuff. The collector. The collector has to use Spark Streaming. We found a cool library which is Twitter Spark Streaming. So nice, Twitter Spark Streaming. It has to read from JSON and put it into Hive, do that kind of transformation if it's needed. And it has to write into Kafka for the message queue. For all of that, we choose Scala. Yeah, that's your face. Why? Because we had a team member who said, OK, don't worry, guys, I got this. I can do it in Scala, so it's OK for me. So we say, OK, do it. The thing is that with this architecture, you don't have to have the same language in all levels of the architecture. You can change between programming language. For the analyzer, it has to translate, to locate, it has to calculate the influence, it has to analyze, of course, it has to classify, it has to read from Hive and put it into JSON or some kind of dictionary. It has to listen from Kafka, and it has to write to the ElasticSearch. And for all of this, we use Python. This morning, I don't know who told us, we are using Python 3.5. We are using Python 2.6.6. OK, that's what they have. So it's something. Let's go to put all of this in a drawing. So that's boring. It's better with the actors. I put some names. For the location, Wally, because Wally knows what is everything. The location is going to call the OpenStreetMaps API, and it's going to get the location of the tweet if he can. The translation, we use the Google API, the Google Translate API. We call them Babel because of the Tower of Babel. For the analysis, we use a kitten. Why? Because this kind of analysis is about the sentiment of the tweet. We want to know if a tweet is talking good about our client or bad. For the classification of birthday, because if we have a kitten, we have to have a birthday. And for the influence, Forbes, because Forbes knows the influence of everybody. OK, but what if we want to grow up? When I think in this architecture, we always think in bigger, OK? Like, what if we want to grow? We are going to need the parallelization, and for that, it's good having atomic actors. Okay, atomics mean that if I have a tweet and pass 2 times for whatever reason in one actor, the result is going to be the same. Okay, it doesn't depend on the others. It should not depend on the others. But anyway, just an example. Imagine that we parallelize everything the analyzer method. We have something like that, a lot of process with that kind of actors. We can have some problems. For example, what if a process fails? What if one of these analyzer process fails? Does everything in the database OK? Can I show all the database to ElasticSearch and Kibana and that kind of things? I don't think so. And what if it fails here? Do I have to do those steps? I did it before. I don't like it to repeat things. But one first approach was having a field in the database. All the tweets has this field. It has finished. When Forbes finished the This one, Forbes, is going to check them. It's a Boolean value, like true, false. And OK, it has finished. But it doesn't solve the second question. If something fails, did I lost all the work? So our approach is doing a consolidation in the database through the states. Okay, I'm going to explain that concept. Each actor reads from one state, state 1, is going to do something. If everything is OK, going to the state 2. If something fails, go to the state 3. Here, you are going to understand it better. I have, imagine, a tweet in the state 1. Here, there is an actor. This actor is going to move the tweet to the state 2 or the state 3 if something fails. When I say fails, is imagine that I have a tweet with the letter A, and I'm trying to translate it. You are not able to translate it. It's A. So that tweet is irrelevant for us. We don't want it, so it fails. Okay. So, but anyway, it goes for the state 2. If the next actor is going to move it to the state 4 or state 5, and yeah, until the end. There will be a final state, something like ready state. And with that idea in the database, we are going to have good states, tweets with good states and bad states. What we can do with that? Imagine that something fails here. Okay, this process just the machine shut down or something like that, and it's broken. I have a tweet with the state 2 stopped at the database. We can do something like a garbage collector, looking at the database each hour in a batch process, and looking for that kind of tweets which are stopped, and put them again to the pipeline. The pipeline is all the actors together. So that's one thing that it resolved. And of course, it resolved the has finished state. We have a read state, so we know when a tweet has finished or not. So again, in our solution, we have the raw state for the beginning of the tweets. Every tweet that goes into the database starts with the raw state. Wally is going to change the state to located or not located. Located if we can, not located if we cannot. Bubble again to translate, not translated, blah, 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 until Forbes. Forbes, if don't know why, somehow is not able to calculate the influence, it's not going to calculate the influence. It will be to the state not influence, and if it's cool, it goes to the state ready. Again, one more time, just to keep it on your mind. At the database, Wally is going to read from the state raw. He's going to write. We suppose everything is OK. He's going to write in the state located. And he's going to say to the bubble, OK, this ID of this tweet is ready for you. Take it. Bubble is going to read it again, write it again, read, write, until the last one, Forbes, is going to write into the state ready, and also is going to write into to index it in the ElasticSearch. I'm going to do one example complete with everything now. So imagine that we have a tweet. The Spark streaming in the Scala and that stuff, get it. He put it in the database. He take the ID, put it in the message queue. And an orchestrator here is listening the message queue. He receives the message, get the ID, and say to Wally, OK, this ID is for you. Get it and do your stuff. Wally gets the ID, do the write, the read, write, blah, 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 until Forbes, and Forbes do the last write at the state ready. And also, Forbes say to the orchestrator, OK, this tweet is ready, like a dictionary, or just Forbes can go to the ElasticSearch itself. It depends how you want to do that. And the orchestrator index it, and finally, we visualize it. More or less, you get it? More or less. Let's talk about the visualization. We have Kibana. I don't know if you know Kibana. Kibana is a nice tool in order to visualize data if you don't know the data. when they told us, okay, you have to use Kibana, I feel like, okay, I have no idea what I'm doing. But finally, it's user-friendly, hopefully, and you can drag and drop a lot of things. And yeah, we got a dashboard. It's not the final dashboard. It's not, of course, not the final version. But we have a map. The client wants a map a lot. They want a map. We have, for example, all the tweets in a plot with the influence or the sentiment. If it's positive, or it's negative. We don't have idea about the tweet. We have how many tweets has location, or how many of them they are retweet. And finally, the Kibana allows you to do some complex visualization about the sentiment. Oh, well, yeah, what a moment. Yeah. Thank you. Well, I can continue without it. Shall I fix it? Nah, it's okay. So, after having all of this architecture, what about the conclusion about the architecture? Sorry. We solved the problem. That's the main question, okay? The main idea of this talk is that I don't want to show you something new, because I'm sure that most of you know that kind of things. But it's just to get some ideas. Then just one of you say, okay, it's not the same, but I can do something similar in order to do my own architecture. So for that's good. So we solved the problem. And there is a good point that with that kind of architecture, we can grow. We can grow everywhere. I don't know if you remember the last drawing. We can, here in this part, we had the collector, but we were using Twitter as a input, but we can use another kind of things. Imagine that we are doing web scraping. We can use a lot of scrapings in order to put a lot of things or data that we want to the database and to the message queue. Or we can use another API or whatever you want in whatever language that you are using. On the other hand, the actors, imagine that the actors are communicating each other between the message queue. Imagine that each actor is read from the database, do the stuff, write to the database, and when they say to the next one, okay, this topic is ready for this tweet is ready for you, it sent the ID to the message queue, and the other one is reading to one message queue in concrete, like RabbitMQ allows you having a lot of message queues, different topics. In that case, imagine that we need more wallies, for example, or we need whatever we want. We can create more wallies, and we can solve that problem. I don't know if I'm explaining very well. But finally, and in the last module, that was there, we sent everything into the ElasticSearch, and from ElasticSearch, it's go to Kibana. But why Kibana? Why don't put something like Django, for example, or something like doing a special graph with D3, or whatever we want? I mean, it's just an indexer. And finally, what should I improve here? Okay, the connection of internet, that's the one point. No, but I will not use Hive. For that kind of things, okay, I know it's big data and that, but we are using the free API of Twitter. We have about 2,000 tweets per day. It's not big data. So I will not use HDFS. I will use something like CouchDB or some NoSQL. I will not use Kafka. I prefer to use RabbitMQ because I think that Kafka is too big for us. We are not going to use everything in Kafka. And I will not use Kibana, for example. I prefer to do a better dashboard with D3 or somehow some tool, more better tool, more strong tool. And well, we can do a lot of things. I don't know if I'm out of time, but yes. So, any questions? Yeah, I finished. Yeah. Any questions?
You can play with it.
Thank you.
You can play with a dinosaur.
Yeah, I know, but I'm talking.
So, any question here?
Hello, thank you for your talk. Did you consider using Apache Storm? Because this is the kind of Apache Storm is the kind of work that I think is designed to do. You have every module that what you want to process is a vault. You have a source of information. I don't know if it's a source, and there's a sink, and it does all the orchestration of all the services. You can decide how many processes you use on every vault and things like that. And it has also, regarding the problem that you said about the delivery, and if something fails, it also has some mechanisms to try to do the acknowledgement of certain processing and response nodes if they fail and things like that. So actually, some of the examples they have in the web page use the Twitter. So it's in the end, it's more or less what they're designed to do this.
No, because of the client. The client told us, okay, you have to use Spark Streaming, and you have to use that tools. So they don't have it. I'm sorry to say that, but they didn't have it, so we could not use it. We try to manage with that kind of tools that they give us. That's what we can do. But anyway, I know Spark Storm, sorry. Yeah, could be nice in order to take them all. So thank you.
Another question?
Thanks for the talk. You already mentioned that a little bit the reasons for not using Kibana and using something on D3, but I would like to, if you can develop it a little bit more, what's the problems you found in Kibana?
The thing is that the idea of this dashboard, this final dashboard, they want to put in a television something, I don't know where, and I think that Kibana is better if you play with him. I mean, Kibana allows you to discover in data. So I prefer to using D3 or whatever you want, something more strong, in order that we will not be able to play with the data. So I don't know if I'm answering you.
Questions?
Hi, thanks. Congratulations for the talk.
Thank
and
you.
also congratulations for being able to implement the actor model in Python, which does not seem a very natural fit for me. It's much for Scala, for example. I would like to ask first if you have used any toolkit in Python in order to help you implementing this pattern, the actor model. And second, if you have experienced that maybe the analyzer modules are bottleneck in your system compared against the performance of the collector, which is implemented in Scala, probably with Akka.
I don't know the Scala part, I'm sorry. No, I didn't use any library, something for whatever for doing that model. And the bottleneck, I think, is will be the database, because if you want to put a lot of actors, everybody has to go to the database again and again and again and again. That's why one of the reasons that we choose CouchDB, because CouchDB at the read doesn't stop the database. So that's one idea. But about the analyzer part, We had two modules, the analyzer and the classification. The analyzer one, that was a proof of concept. The analyzer part was calling to an API, meaning cloud, to get the sentiment. And the classifier part was using scikit-learn in order to do the classification. So the bottleneck, I think, that will be the modeling, preparing that classification, but just going to the pickles and check them, I don't think so. We didn't test that with a lot of content. I would like to.
Questions?
More questions?
I in fact have one. If I understood you, for each step of that, call it a state machine, you send from one element to one stage to the following, a kind of an ID of the tweet, and then send the tweet to the database.
Yes.
My question is, why don't you just send the tweet?
Okay, because we have to put the tweet in the database, yes or yes. Okay, you get it?
That's what I'm not getting. Why you need to store the tweet?
Because if we lose, for whatever reason, we lose something, we lose the process. Imagine that we have there are 5 actors, imagine. We lose the process in the 3rd actor. The tweet in the database will be in the first state. You will not do any write to the database, okay? If you send the tweet between them. So you have to write them at each step.
Not if you code the stage in the message.
Oh, to the message queue.
Use the message queue. That's what I don't get.
Yeah, that's one. That is a possible solution, but the idea is not only talking about tweets, okay, that's about tweets, but what if you use another kind of structure that is not able or is too big to put it like a really big message? I don't think that is a good idea because I prefer to consolidate everything in the database and not in the message queue.
Then we won't agree. I'm a fan of messages.
Okay. So thank you very much. I'm sorry for that.
So let's thank the speaker again for this great talk.
Thank you.